So welcome back to my YouTube channel. So today I'll be going through the Cape Chemistry Unit 2 2020 Paper 1. Question 1. Alright, so it says, in which of the following pairs of formulae is the molecular formula and empirical formula correct for butanoic acid? Butanoic acid is a carboxylic acid, so it has the COOH group, right? And so you would expect there to be C and of course some amount of H. Now since you have the COOH group here, you have to actually take 1 from 4 because but is 4. And so it's C3, H, it's 2N plus 1, so 2, 3, 6 plus 1, 7. So it's C3H7COOH. That's the structural formula. As a molecular formula now, C, 3 C's here, 1 more here, so that's 4 C's. We have 7 H's plus 1 on the end, that's 8 H's, and of course 2 oxygens. So you're looking for C4H8O2. So that would leave us with C4H, A or C as the correct answer. Now the empirical formula is the smallest ratio that you could find, so I'll just advise you to just divide everything by the smallest number of the 3, which is 2. So 22 is 1, 2 into 8 goes 4 times, and 2 into 4 goes 2 times. So the empirical formula would be C2H4 1 oxygen. So that leaves you with C. Question 1, C. Question 2, well, says items 2 to 3 refers to the following information about hydrocarbon Z. And it's very important that you pay attention to things like this because a hydrocarbon has both hydrogen and carbon. Nice. So hydrocarbon Z has a relative molecular mass of 84. That will be important later. When 0.1 grams of Z was burnt in oxygen, 0.316 grams of carbon dioxide and 0.128 grams of water was formed. First part of the question, which is item 2, wants you to calculate or figure out what the empirical formula of hydrocarbon Z is. So basically you just need to find out the ratio of carbon to hydrogen. So the first thing you need to ask yourself is what mass of the things produced was actually carbon and what mass was hydrogen. So to figure that out, let's deal with hydrogen first. We would have gotten the hydrogen from the water because if hydrocarbon Z, let me just move over here because I just need space. If hydrocarbon Z is burnt in oxygen, that would result in the formation of carbon dioxide and water. So essentially the water or hydrogen would be from the water, so we'll get hydrogen from that, while the carbon, we'd get that from carbon dioxide. So with that said, you need to work out the masses that we're getting here. So essentially, we were told that we had 0.128 grams of water formed, and there was 0.316 grams of carbon dioxide. So if we need to find out how much hydrogen was from this water, we'd essentially need to find out how much hydrogen, or what's the regular mass of hydrogen over the molecular mass of water, and multiply that by the mass of water formed. So essentially that would be the molecular mass of hydrogen is 1, but we have 2 of them, so we'd have to multiply that 1 by 2. So that would be 2 over 16 plus 2, which is 18, multiplied by 0.128 grams, and that would give you 0.014 grams. So that means hydrocarbon Z or Z had 0.014 grams of hydrogen. Similarly, if we need to figure out what we had for carbon, it would be the mass of carbon, in typical sense, over the mass of carbon dioxide, which is 44, I think, multiplied by the mass of carbon dioxide given. So that would be 12 over carbon dioxide is 12 plus 32, 44, right? Multiplied by that 0.316 grams given, that would give you 0.086 grams of carbon. Now that we know this, I always tell my students to work in moles. So we need to convert these masses to moles. And you know that number of moles would be equal to the mass of the substance divided by molar mass, right? And if that's the case, the mass of hydrogen that we found, 0.014, divided by the molar mass, and molar mass is the mass of 1 mole of hydrogen, that's 1 gram. So the number of moles of hydrogen that we have is 0.014 moles. It's a bit different for, you're not always going to get the same number, it's just that hydrogen is 1, so you always get the same value. However, for carbon, the mass that we have is 0.086 grams. So if we divide that by the molar mass of carbon, which is 12 grams per mole, that would give us the number of moles of carbon as being 0.07 moles. We have the carbon to hydrogen. So now that we know the number of moles of each, where carbon is 0.07 moles and hydrogen is 0.014 moles, you just need to divide both values by the smaller of the two numbers. So 0.07 divided by 0.07 and 0.014 divided by 0.07. That's going to cancel out to 1. This will 277, 1742. So that would mean that for every carbon we need 2 hydrogens. So the empirical formula, pretend that I wrote that out, is CH2. So I always advise you to work this out before you even look at the multiple choice answers, because they're there to influence you. Now, question 3 wants you to work out the molecular formula of the hydrocarbon Z. Now that you've gotten the empirical formula as CH2, the empirical formula mass would be 12 plus 2 hydrogens, so 2 times 1, which is 2. And that is equal to 14. We were told earlier in the instructions that the relative molecular mass of hydrocarbon Z is 84. So, in order to figure out the molecular formula, you need to figure out how many times you can get the empirical formula mass out of the molecular mass. So you're going to divide 84, pretend that I wrote that 8, not ugly, 84 by 14. And you should get 6. So that would mean that for the CH2, that's the empirical formula, you need to multiply everything by 6. So you need 6 times 1 carbon is 6 carbons, and 6 times 2 hydrogens, 6 2s 12, H12. So the molecular formula would therefore be C6H12. Now for question 4. Alkane molecules are cracked into smaller molecules, which may include smaller alkanes, alkenes, and hydrogen molecules. Which of the following equations show the cracking of C12H26? Okay, the first thing I always do is check if what's on the left matches what's in the question. So since all of these are C12H26, then I'll have to go through and check them one by one. So if you start at A, what you're aiming for is to ensure that one, you need to ensure that the alkanes follow the general rule of alkanes, where the formula is CnH2n plus 1. And also you need to ensure that the alkenes follow the alkenes general formula, where it's CnH2n, right? So first things first, the formulae or the formulas, they need to be correct. If you find that they're correct, you need the same number of atoms on the left as you have on the right. That's the second thing. So just to ensure that you're clear on the two criteria. Number one, alkanes need to have the correct formula, and so do alkenes. And the second thing is that the equation has to be balanced. Let's put it that way. Because I don't want to have... Well, let me not. Okay. So, checking A for those two things. So, you have 8 carbons here and 4 here. 8 plus 4 is 12. And you have 18 hydrogens and 8 hydrogens here. So that's 2, 8, 16, 26. Yes. So you do have 12 carbons and you do have 26 hydrogens. C8H18, that's octane, because 2, 8, 16 plus 2, 18. Yeah. And C4H8, that's butene. So yeah, off the bat, the two criteria that are suggested here, 1 and 2, are very much seen here. So that's correct. For this item 5, sorry about that, refers to the following structure based on the IUPAC rules. Name the compound above. Alright, the compound here, a lot of people don't realize that there is a carbon here, so there should be a carbon. It's a skeletal formula, so they don't have to show it, but it would have been nice if they did, right? So there is a carbon there between the phenyl group, and here we have an amine group. But with both of those, whenever you're naming, you need to start with the longest carbon chain. Identify that first, and the longest carbon chain in this compound is 3 carbons long, so you're looking for prop. So A and B are out. Now here the phenyl group is on the first carbon, so it's 1 phenyl and not benzyl, and the amine group is on the 1, 2 second carbon, so you're looking for D, 1 phenyl propan 2 amine. Now an alcohol is treated with acidified potassium dichromate, that's K2CR2O7, and the resulting mixture gives a positive triiodoform test. See, since it's positive, then you're looking for one of two things. First thing, ethanol. Ethanol is the only primary alcohol that would give a positive result with the triiodoform test. Second thing is you're looking for a secondary alcohol that has a methyl group attached to the carbon that is attached to the OH group. So for A here is methanol. It's considered a primary alcohol. So it's not ethanol, so it can't be that. B here is a secondary alcohol because the OH group is bonded to a carbon that is bonded to 2 other carbons. So our secondary alcohol here would go with B. But let's look at C and D just to be sure. C here, you have carbon that's bonded to 1 other carbon. This is a primary alcohol. But the thing is, it is not ethanol because you need 2 carbons for it to be ethanol. So yeah, C is incorrect. And D here is a 1, 2, 3 tertiary alcohol, and the triiodoform test does not give a positive result with tertiary alcohols. So the correct answer for this one, number 6, is B. Okay, number 7. Which of the following reaction mechanisms occur between benzene and concentrated nitric/sulfuric acid? This is electrophilic substitution. So number 7, D. For number 8, Which of the following statements about polyunsaturated oils, which are triglycerides, is false? A, they undergo saponification, maybe. They have hydrogenated, they are hydrogenated to produce margarine. Yeah, I'm sure about that one. They are hydrolyzed to produce diglycerides. No. Nah, brother. So A is correct. B is correct. Their shelf lives are prolonged by or with hydrogenation. Yeah, C is false. Reason being, this name now. Triglycerides are hydrolyzed into fatty acid and glycerol. What's up with me? I was about to say what's up with me today. I can't speak, but I can't speak every day, so. Item 9 refers to the compounds P, Q, R, and S with the following structures. S here looks like phenol to me. P is an alcohol. As for which one it is, C, 4, 5, and 6. I would say hexanol. I probably should check that a bit better than this, but we're going with that. This one is a carboxylic acid. And this one also carboxylic acid. Oh, here we have halogen. Halogen is here. That's important. Okay, so the correct sequence of the compounds in the order of decreasing acid strength is decreasing mean big to small, right? Decreasing, yeah, big to small, so most acidic to least acidic. Okay, in that case we're going R number 1, Q number 2, S number 3, and P number 4. Alcohols are not acid, so yeah, P has to be the last one, and I kind of trip you up here by putting P as the last one for a whole 3 of them. But yeah, so you're ending with P, but starting with you definitely can't start with S. Which one? R. You're starting with R. So C. See what they did there. Number 10. I think I'll have to zoom out for you to see this one. But yeah. Oh, this looks nice. Item 10 refers to the following table, which shows the results of an investigation to analyze an organic liquid Z. Z is a liquid. Solid sodium carbonate was added to Z. Then you had rapid effervescence, which is bubbles. Gas evolved, formed a white precipitate with calcium hydroxide solution. CO2 is liberated. I'm thinking carboxylic acid. Then SOCl2. I think this is called thionyl chloride. Don't quote me on it though. I can't spell. Chloride is added to Z. White misty fumes form. This misty fumes is SO2, sulfur dioxide. OH group is definitely. So this is a carboxylic acid. SOCl2 reacts with the OH group present in the carboxylic acid, because you know that it would be carbon, then double bond O, and then you have an OH group, right? And R group, which is the rest of the molecule. The thionyl chloride reacts with this, and sulfur dioxide gas is given off as a result. And then you know the normal acid plus carbonate gives you carbon dioxide, water, and a salt. If you did CSEC chemistry, you'd have learned that one. Alright, number 11, pentane has the molecular formula C5H12. How many possible isomers does this compound have? 3. Just swap this. You could work it out, but just swap it. Which of the following methods could not be used to differentiate ethanol from propanol? Determining molecular mass, determining empirical formula, measuring boiling point, or using Tollens reagent. Tollens reagent is used to differentiate between aldehydes and ketones. Since ethanol and propanol are both aldehydes, you would see a difference in how they react. The functional groups present on an amino acid are the amine group and the carboxyl group. This allows amino acids to exist as Switcher ions. And the product formed by the polymerization of protein C3H6 may be used as a plastic material, disinfectant, liquid, or fuel. Plastic material, I think it's polypropylene. what would be observed when aqueous bromine is added to the following compound? So that's phenol. So when bromine is added to phenol, a white precipitate is formed and bromine is decolorized. So that's what you're looking for in your answer. A, there would be no visible reaction. That's a lie. The color of bromine would be discharged, leaving yellow precipitate. Nah, told you white. The color of bromine would be discharged and a colorless solution formed. Maybe. Nah, that's not what I said. The color of bromine would be discharged and a white. Okay, I was getting a bit nervous there because I'm like, maybe the answer is C. Like, nah. Which of the following statements is not true about the detection limit of an instrument? Is related to its sensitivity? I believe so. It is equal to the standard deviation? Maybe not. It is usually expressed in parts per million? Could be. It is the lowest concentration of an analyte that can be detected. Yeah, I'll go B. 16. We're looking for number 17. Okay, here we go. Item 17 refers to the following diagram, which represents a paper chromatogram of food dyes obtained using water as the solvent. A spot of a sample was originally placed at Z or Z, whichever one you say. It contained the components X and Y. X, Y, Z. I don't study this. Well, right now I know what the answer is, but how I usually, before, like, I could, like, just know, I used to give them arbitrary numbers like 2, 4, and 6. And retention factor RF is the distance traveled by the solute divided by the distance traveled by the solvent. So for Y, I would essentially put 2 over 6, 1, 2 into 6, 3, which is 0.3, and X, which is 4 over 6, which is 2/3, which is 0.6, I believe, 0.67. So as you can see, X has a larger retention factor and it traveled the furthest. X interacts more with the mobile phase, which is whatever the solvent is that is carrying it along the paper. Y interacts more with the stationary phase, which is the paper, hence why it's held back. So, with that said, the one with the higher retention factor being X, right? Let's see what this is saying. Y is more strongly absorbed by the paper than X. That is what you're looking for. Y is more strongly absorbed by the paper than X, hence it has the smaller retention factor. So then, which one? X has the larger retention factor. And Y has a smaller retention factor value than X. Yeah, Y smaller retention factor. What does it say? Y has a larger retention. No, it does not. So the answer for number 17 is A. Number 18. Treatment of a 10-gram sample containing a chloride salt with excess silver nitrate solution produced 8.08 grams of silver chloride. Which of the following expressions can be used to calculate the percentage of chloride in the sample? Bear with me. Alright, so essentially, if silver chloride were soluble and it hypothetically were able to like dissolve in water, then it would break apart into silver ions and chloride ions. Yeah, as you can see, if it's balanced, everything is in a 1-to-1 ratio. Since we're given the mass of silver chloride, we can use that to essentially find out how much chloride ions would be formed. To do that, you have to work in moles. So I can't stress this enough. If you're given grams and you're not sure where to go, I would advise just start by trying to convert some things to moles, right? So to convert the mass of silver chloride given, which is 8.08 grams, to moles, you have to divide it by its molecular mass, which is 108 plus 35.5, which is 143.5. 143.5 grams per mole. Then once you have the number of moles, it would be equal to the same number of moles of chloride, since everything is in a 1-to-1 ratio. So in order to get the mass of chloride ions formed, you have to multiply by 35.5 grams per mole, which is essentially the molar mass of the chloride ion. Then after getting the result for this, remember they asked you the percentage of chloride in the sample. So you need to put the mass of chloride in the sample over the number or the total mass in the sample, which is 10 grams, and then multiply by 100. So that's how the 10 ended up on the bottom. So far we have 8.08 and 35.5 on top. That's looking like B. 143.5 and the 10 on the bottom and multiplied by 100. So 18 is B. Number 19, a 300 milligram solid sample containing a chloride is dissolved in water. The chloride is then precipitated as silver chloride by the addition of silver nitrate to the solution of this sample. The precipitate is collected, washed, dried, and weighed, and found to have a mass of 525 milligrams. The mass of chloride present in the sample is okay. They gonna make you work for it. That's okay. It's essentially following the same principle that we found up top. So I'd advise doing some conversion to basically keep your units same. So we're going to need the molecular mass of silver chloride, which was 143.5 grams per mole, but we need that as milligrams per mole. So how I do conversion is like this. So since grams is here and I want to get rid of it, I'll put grams at the bottom and milligrams at the top. And I know that 1,000 milli is 10 to the 3, so milli is 10 to the 3, so 1,000 milligrams will give me 1 gram. Gram cancel gram, so I know in order to convert 143.5 milligram, 143.5 grams to milligrams, I need to multiply by 1,000. So yeah, I don't know the big to small multiplier, I don't know that. I just do my conversions like this all the time. So basically 143.5 times 1,000, that's 143,500 milligrams. So then you want to go ahead now, since we're going to do the same thing. Remember I told you if silver chloride were to be dissolved in water, you get Ag plus and Cl minus. So essentially whatever mass of AgCl that we have, which is 525 milligrams, we need to convert that to moles by dividing by the molar mass. In this case it would be 143,500 milligrams per mole. 525 milligrams divided by 143,500 milligrams per mole. Now you'll multiply that by the molecular mass of the chloride ion, which is 35.5 grams, but again I need that to be in milligrams, right? So that's 1, 2, 3, so that's 3, 5, 5 and 2 zeros. So I'll multiply that by 35500 milligrams again per mole. Milligrams per mole cancels milligrams per mole, and if you put this into your calculator, that will give you 129.878, which is 129.9 milligrams. So answer is C. Which of the following inaccuracies may be eliminated by calibrating a measuring instrument? It's always systematic error. Oh girl, read. Lack of precision. Don't do that. Ensure that you read A to B. Random errors only, systematic errors only, both random errors and systematic errors. Yes, C. 21. Which of the following sets of regions in the electromagnetic spectrum is in the correct order of increasing wavelength? So I'll just, okay, you have radio waves, microwaves, and this is largest wavelength to smallest. I know them in this order. I apologize. Microwaves, IR, so just before visible light is then UV, ultraviolet, because infrared literally means below red. Fun fact, visible light because you have Roy G Biv for the rainbow, and so red is here and violet is here. So ultra means above, so ultraviolet means above violet, so literally after violet. So that's how I remember it. Then you have X-rays, then gamma. Okay, so increasing wavelength, increasing would be small to big. So we're going backwards then. Ain't no way we ending at X-rays. We possibly could end at IR, but having X-rays just before IR is crazy work. So B, which of the following species is not a significant fragment from the mass spectrum of ethanol? So you will have OH, you will have this one. This one would be the M plus peak, the molecular ion peak. Alright, so I'll go with CH3. An unknown organic compound with molecular mass of 44 grams is analyzed using infrared radiation. The bonds are found at 1,700 per centimeter and 2,800 per centimeter. The compound is most likely an aldehyde. Let's just get that out there. Now, you can get this from the data booklet, the numbers, but this is a repeated question and it hasn't changed. But yeah, the 1,700 is for the carbonyl compound, like the carbonyl bond C double bond O, and this 2,800 is for CH bonds primarily seen in aldehydes. So your answer is ethanal, not ethanol. Ethanol is an alcohol. Ethanal is the aldehyde. Pretend that I spelled that correctly. As for 24, in the infrared spectrum of an organic compound, a strong band is observed at 3,000 per centimeter. Oh, I should have explained this. Anyways, this one, radiation is absorbed and causes the CH bonds to vibrate. So the 3,000 per centimeter is usually seen around the area of the CH bonds for alkenes and CH bonds for alkanes. So between that area. So that's the range. Which of the following processes occur in a mass spectrometer before isotopes can be detected? Acceleration, never heard of this. Deflection, yeah, with the magnet right at the bend. So 1 and 3. Okay, B. A student carries out the gravimetric analysis of a soil sample taken from an area surrounding a garage. The soil sample is found to be contaminated with Pb2 plus ions, lead ions. 100 centimeter cube of a solution obtained from the sample when mixed with 25 centimeter cube of 0.1 mole per decimeter cube HCl yields 0.010 grams of lead chloride. The relative formula mass of lead chloride is 278.2. The balanced equation for the reaction between lead ions and hydrochloric acid is... Why didn't give you all of that? Alright, PB. Alright, first of all, wow. Between lead ions, okay. Lead ions, so this is out a no, this is a no. We need Pb2 plus, that's it. Aqueous, 2HCl aqueous, yeah, PbCl2. Wow. Oh, the difference, aqueous versus solid. Lead chloride is an insoluble salt, so you'd need it to be in the solid state. So D. Which of the following features are advantages of steam distillation? It provides savings in fuel costs. Yep. It occurs under reduced pressure. No. Nope. Reduced pressure distillation is the same as vacuum distillation, I believe. And vacuum distillation is not the same as steam distillation. So these are two different things. So 2 is out. The components do not decompose there. 1 and 3 go with that. So B. Number 28. Compound X contains 3 components P, Q, and R. Compound P is needed as the starting material for the synthesis of a new drug. Which of the following methods of chromatography is most suitable for obtaining pure sample of P? Paper is out and thin layer is out because those are more like visualization techniques. So you're left between column and gas liquid. I would go column, more because gas liquid is used for volatile compounds and gases, and I never say nothing about that in the question. Which of the following bonds would show the strongest absorption in IRs? OH. That's the one with the fat band. When you look at the IR spec, it look kind of like this. Yeah. Number 30. Which of the following statements about the partition coefficient may be true? The partition coefficient does not vary with temperature. Does not. Yeah. No, that ain't right. The two solutions have to be concentrated for the partition coefficient to be a constant. The solute has to be in the same molecular state in both solvents for the partition coefficient to be constant. I don't like how them said this, but I'll go with 3. Because one ain't correct. The partition coefficient does vary with temperature. The two solutions have to be concentrated for the partition coefficient to be constant. The way they said this, it makes it sound like the partition coefficient can be a variable, which is not the case. So I don't like how that's phrased. So 3 seems like the most likely one. Number 31. The extraction of aluminum is in an electrolytic process where the electrolyte used is purified or dissolved in cryolite. Which of the following descriptions is true for the use of cryolite? Provides an additional source of aluminum. That's not true. They told it's used to dissolve. Reduces the melting point of the mixture. I'll go B. And increases the electrical, no. Produces an additional source of aluminum and reduces the melting point of the mixture. No, it's the additional source of aluminum for me. No. In one of the steps involved in the manufacture of sulfuric acid, sulfur dioxide and oxygen are mixed to form sulfur trioxide according to the following equation. Which of the following options describes the effects of adding the catalyst to vanadium pentoxide to the mixture? Equilibrium is not changed, so it's either B or C, but the rate of the reaction has to increase because a catalyst was added. So, rule of thumb, catalysts don't affect the equilibrium of a reaction, it only speeds up the rate of the reaction. So B. Chlorofluorocarbons undergo homolytic fission by being exposed to UV light in the stratosphere. Which radical could result from that? CH2F2Cl. So chlorofluorocarbons undergo their CCl bonds undergo homolytic fission, where each of them take an electron with them. Should have done that with half arrows, but bear with me. Right, in that case, whichever of these answers don't have a chlorine atom is the correct answer. So A. 34. Cracking is a process used to break down large hydrocarbons into smaller molecules. Which of the following is a balanced equation for the cracking of dodecane into nonane and propene? Dodecane is a 12-carbon compound, so the answer is C. Yeah, that's the only one that has C12. What is the product of the following unbalanced equation? This one, I just OH minus. Whenever OH reacts, or whenever an ion is attached or becomes a part of a neutral molecule, you'll find that the molecule's overall charge will be that of the ion. So the answer D. Essential conditions for the Haber process are 200 atmosphere pressure, 450 degrees Celsius, and an iron catalyst has to be present. C. Number 37. The presence of phosphate ions can be detected using ammonium molybdate, and you'll have a bright yellow precipitate being formed, given that it's a positive result. Which of the following methods are used in water purification? Filtration, yeah. Distillation, yep. UV radiation, all three, yeah? Oh, this is nice. From the reaction given below, a high pressure would give the best yield, but in industry a moderate pressure is used. Why is moderate pressure used in industry rather than high pressure? It's too expensive. Read the rest, don't be lazy. The reaction would be uncontrollably fast. Not necessarily. The reaction would be too slow, that's not it. It's easier to know. Compounds of sulfur, such as sulfides, are used as food additives because they inhibit the oxidation. They act as antioxidants. Yeah. Chlorine can be produced by the diaphragm method and mercury cell electrolysis. Which of the following statements is or are true regarding the diaphragm cell method? It is less energy. No, that's not true. It's more energy efficient, yeah, and it's less harmful, yeah. 2 and 3. So D. In which layer of the atmosphere does ozone act as a pollutant? Boy, my brain lagging. Troposphere. Tropospheric ozone is known as bad ozone, while stratospheric ozone is known as the good ozone. Which of the following is not a primary pollutant? Nitrogen dioxide. For some reason the paper is missing number 44 and 45, so this is where we'll end it. If you like the video, don't forget to like, subscribe to my channel, of course share it with a friend, and you can always hit me up on Instagram. Any of my socials, everything is in the description box below, or leave a comment on what you'd like me to do next. Until next time, bye guys.